Hello, YouTubers and students of organic chemistry out there. Dave in Pennsylvania, USA. I'm using I'll show you their icon. Can you see it down here? The Beyond Labz virtual organic software. I'm using the synthesis module. And I've already entered the laboratory. And we're going to show you an alkene dihydroxylation. So what I will do is select cyclohexene, double click. Let's try to drag it with the syringe. I have trouble with that. Let's see if it's there. Well, how do you like that? I got it to work. Early on, I had a lot of trouble with the syringe delivery. If you don't use the syringe icon, double click on the reagent. I'm going to put it in diethyl ether. I'll double click. Check the blackboard. You can see the reactant and the solvent. Let's bring it down to the stir plate. And we have to add a reagent to make a glycol, a 1,2-diol osmium tetroxide. The three are there. We'll put a heating mantle, reflux condenser, nitrogen gas, begin reaction. Now, we can take a TLC at close to time zero. You can save it to the notebook if you wish. So if I click on save and then OK, if I open up the notebook, you'll find that it'll be there. Of course, when you get done, you have the reaction, the date, observations, things like that, characterization, workup procedure. You can save that to your desktop and send that on to your instructor, or if you are the instructor, you can hold that for teaching students. I'll X out the lab notebook. You could do reactions at room temperature, ice bath, or with heating. Now I'm going to go ahead an hour. You watch up there. See, there's your product forming. And you can tell it's a syn addition if you studied this in organic electrophilic additions chapter. The osmium tetroxide is going to deliver by syn addition the cis glycol. And there it is. Now I'm going to go ahead an hour because there's still cyclohexene. And you can see after 1 hour's time, you can go up minutes, tens of minutes. You have diethyl ether and the product. Now, I would have my students look up the melting point of the product. I would always have them record both starting material, physical properties, boiling point density, etc., molar mass. And you can get some of that information from the SDBS online structural database, Japanese Analytical Society. It's an excellent database for proton, C13, mass spec, infrared, ESR, etc. Okay, now the reaction is complete. So I'm going to click on the SEP funnel, and I'll add water. The lower layer is just water. We didn't pull anything out. Top layer is going to have the product in diethyl ether. So we simulate rotary evaporation by taking that top layer and putting it right in the crystallizing dish. Now, see the white solid there? Now, what that means is we put it in a hood, a fume hood, or used a rotary evaporator to remove the solvent. And if you had done your homework, you would know that this target molecule, the product, is a solid. Let's do a melting point. So we click on that and bring that over to the solid. And that melting point, can you see it down there, is 98.0 degrees. That's for this target molecule. You can do another TLC. There's the RF value. Let's do FTIR. Very broad OH. Well, not as broad as some of them can be. If you're doing a thin plate, it would be... well, if you did it as a neat liquid, it would have very heavy-duty hydrogen bonding and a much broader OH. But let's not get into infrared right now. But that would be the IR. The SDBS will have the IR, and it will tell you the conditions, whether it's done in a solvent like carbon tetrachloride, or if it's done neat, neutral, mole, KBr pellet. SDBS would help you with that, and you can compare it to this FTIR. Okay, I'll click OK. Let's do a proton NMR. and they don't have one. So you'd have to look that up in the SDBS. Let's try C13. Nope. So they don't have the NMR data for that. Let's try mass spec. And there it is. Molecular ion, 116, and then your base peak is showing up at 70.095. Interesting. So that is a demonstration of the reaction. The product can be seen up here. If you hold the L button, it's the 1,2-cis. Once again, because as I said, syn addition, and that would then give you only the cis diastereomer, not the trans. Thanks for watching, guys. When you want to do a new experiment, you click on this to clean the lab and try one of these other reactions. And if you're going to exit, you go over there. Then you exit up here. I didn't keep the notebook. If you did, it'll go to the desktop. And then you exit up here. Tech service for the company is excellent. And the student fee in the United States is $25 US dollars, $25 a year, which is excellent for this program for undergraduates. Students completing Organic 1 online because of the pandemic with me, when they go on to Organic 2 lab, they will go in that lab with familiarity. And I show them other things: Google, patents, electronic journals, ChemDraw. I show them things like that, make videos of conformational analysis. So anyway, thank you for watching. Look for other videos. Bye for now.